Welcome back, friends. Today we'll be mapping the population density of Japan in ArcGIS. So I have a guide how to do it here at the website of Geonity. Though in this guide you can see it's mainly for ArcGIS desktop, but you can use it for ArcGIS Pro as well. In this video I'll be guiding you through how to do it in ArcGIS Pro. So for desktop you can read this article, but for Pro this is the video for you. Let's get started. In ArcGIS Pro, just open and create a new project. Let's create a new map project. Click map, and then here you get the name, the project name you want to have. So I'll call it population density in Japan, right? And where do you want to save it? Save it to your location. I'll be navigating to my location, and then after navigating I pressed OK. In this case I don't want a separate folder, so I'll be unchecking this and then click OK. Then in just few seconds it will quickly spin up a new project for you. There we go. Now let's import some data of Japan. I'll be going to map and click add data, then navigate to your place. Here I have navigated to my place, and let's add Japan V62. We'll also explore the attribute table. So let's see, in the attribute table there we can find that for each location, each polygon contains administrative areas. So the polygon has administrative boundaries, and you see population for each of those places along with other informations as well. So how can we leverage this population data to create a population density map? First, let's change our environment settings. For that you can go to analysis and click environments. In environments we will be first expanding output coordinate, and in here what do we see? We should be putting the processing extent, and we want the processing extent to be as a layer, which is Japan layer. That's our processing extent. Output coordinate system, let's call it same as display or current map. That should be fine. And if you scroll a little down, then under raster analysis you have mask. In the mask we would like to select the same, but since it's not showing the drop down menu, I'm going to manually go and select the same boundary for administrative and click OK. That's going to be the mask layer as well. That's pretty much it, and then we'll click OK. So we have just completed the step 2 of this tutorial. Now let's go to step 4, generating population points. How can we do that? As you can see, if you have an advanced license, then you can accomplish this. Otherwise, you cannot, and that's why there's also another feature called pop centroids already provided with the data. You can directly use that, but since I have advanced license, I'm going to use the feature to point tool. Let's do that. Go to geoprocessing. If it's not showing here, then you can always go to analysis and then click tools. Then you can find tools. Let's find feature to point feature to point. Feature to point tool. This is the one from data management tools. Click it. Then our input feature is Japan. And then output feature, we'll call it, let's make it short, and we'll call it population centroids. And please click inside, because when you click inside, it specifies where the output located within the input feature, or so click inside, and that should be it. Then we'll click run, and it will convert all those polygons to points through the calculating the centroids. So we have 1 point for each polygon in the centroid. Now will be, if you don't have advanced license, then you can always import the point directly by clicking add data. So we won't be doing that since we have already converted polygon to point. Now we'll be using a point density tool to create a simple density surface. Let's go back and search in geoprocessing. Point density. Open the tool. Select pop centroids. Population centroids has the input point feature, and population field, it's in population, right? So that's the one. Output raster, let's call it simple population density 50. We'll set the output cell size to 2500. Neighboring circle radius, let's set the radius to 50,000. You can find these parameters in here as well. So first we are building with a large radius, using large radius to make the surface. Units, it's fine, square kilometers and map. Then let's run it and let's see. Okay, now we have it. Let's close this, and let's also turn this layer off. Now if you can see there, you have the density surface, and it is displayed using equal interval classification scheme with 9 symbols, as you can see here. But to help us see the surface, we should change the color ramp. Let's right click it and go to symbology, and in the color ramp we'll choose yellow to dark red. So click there and click show name to see the names, and yellow to dark red. Let's select that. It will help us to visualize it. better. And now we can see where the population density is higher and where it's low. The darker means that's where there's more population density, and the larger part means that's where there's low population density. We'll also experiment with various classification schemes so that we can examine population patterns in density surface. Let's open symbology again, and now in classification, instead of using the method of equal interval, we're going to use standard deviation. And now we have some changes in here visually, right? So what do we see? This scheme emphasizes the areas of particularly high or low value. So we can clearly see that high population density is being emphasized and lower one. Also, it can be differentiated very easily. Now let's change the classification method to quantile, and the number of classes, let's change it to 9. So what have we done? We have changed to 9 quantiles. With the quantile method, each class has the same number of cells on it. So each class has the same number of cells on it. More cells are forced into the highest classes, obscuring the highest centers of density. So each class has same number of pixels, same number of cells in it. That's why we can see this kind of surface being formed. Now also let's try seeing the natural breaks classification method. So we'll select natural breaks. It's at the top of the list. If you don't see it, scroll up, and there we have natural breaks Jenks method. Now here in this method, the class ranges are based on groupings of data value. In the population density surface, this scheme emphasizes the areas of highest density while also revealing the subtle patterns of density distribution as well. So it's not ignoring those low density locations either. So that's how we can visualize the population density. Now let's try experimenting with other things as well. Go to geoprocessing, and they're using the same population to density. We will change the name to density 25. Why? Because we're going to change the radius to 25,000. Now there we have it. Population density using now let's symbolize it as well again in symbology. Let's change it to natural breaks. Let's change the color to yellow to red, yellow to dark red. Okay, now we've selected that. Now let's try comparing both of them. Here we see the difference, right? When we use smaller radius and larger radius area, we can see that density 25, it's created with smaller radius, shows more localized patterns, and is not as generalized as the simple population density 25. It's more generalized and with larger radius. Now let's move to next step. Now since we have created population density surface using simple method, we'll create a population density surface using kernel method. That's the second method of creating population density. Kernel option employs a circular radius neighborhood around each point and calculates each cell value by adding the values of the overlapping neighborhoods. It typically results in smoother surface than the one created by simple option. For that, we'll go to geoprocessing and again search for kernel density. Instead of point density, we'll be searching for kernel density. Open that tool, special enlist tool, kernel density, and in there we'll fill up the default data. We'll call this kernel population density 25. That's what we're going to call it. And the output size, cell size 25,500, radius 25,000. And then that's it. Then okay. Now then we'll run this tool, the kernel density tool, and here we have the kernel density population. Let's again change the color ramp to be the same. Make it natural bricks and the color ramp to yellow to dark red, right? Where is it? Yellow. Okay, we're almost there. Yeah, yellow to dark red. Now let's compare. What difference do you see using kernel density and simple population density and kernel density? What's the difference? It has much smoother and generalized appearance. The kernel density is much smoother than the population density, and in many cases using kernel density produces a map with patterns that are easier to interpret as well. So today we have learned about these things, using kernel density to create a surface and using simple density surface through various radius as well. That should be the end of that is the end of this video. I hope you like it. I'll save the map. For that you can click the save button or press Ctrl S and save the map, and you can always visualize the map at your convenience. Thank you for watching.